can say our fourth chapter is CO4, where we have to understand the types of different types of memories or their uses. Okay, so what are the uses of memory? That is our CO4. So now in the beginning we have to look for the classification of memory. So we have to remember our key. What's that? It is Malhar. Okay, Malhar. H is silent, so Malhar. It is Malar. Okay, H silence, Malhar. So first, what does M stands for? We have classification. This is very important question, definitely there in your examination. So first we have to understand what is M stands for. Then A. Then again we have L, then A and R. We have to recognize these letters first. So first M stands for material. Okay, what kind of material used for making a memory? So for making memory, it can be bipolar or magnetic material. Okay, based on material it is created. So there may be magnetic or semiconductive. Semiconductor or magnetic material can be used to create memory. Okay, so based on this we have material type. Then next is based on access type. A stands for access. How you access your data or how you access particular address to have your data, required data. So this address access type can sequential access and another is a random access. Sequential and random. So in these two types, sequential in the sense we have to pass the current location. If you know the previous location, then only you can have the next location. So it deals with the sequence. Okay. While in a random access, you don't need to pass the previous address. Where you stop, then you can use the next one address. So it would be sequential or a random. Okay. The next is location based. L for location. So in location based type, in location, so what are the possible location for memory, or we can say it is broadly types of memory. So different memory location are a register. Then next is main memory. Main is also kind of memory, and the last one is secondary memory. Understand secondary memory in the sense pen drive, floppy, or your removable drives like CD, DVDs. Okay, so these are the location based memories. Register, which is inside your processor. Then next is main memory, your RAM, and secondary memory. The hard disk or can say external storage devices are treated as a secondary memory. Okay, and the next A is again about aging. Okay, so aging in the sense whether the contents, memory contents are static or dynamic. Will it retain for longer in memory or will it refresh? Will you lose after refresh? So if we lose the contents, or if we are talking about the dynamic memory, so it is made with the help of capacitor, so it needs to refresh all time. Okay, and when once you refresh, it will lose the contents whatever written on it. And there is one example for static memory, and static memory devices like resistor, MOS are example of this static one. And the dynamic memory is can consider like RAM is would be is our dynamic memory. The last one is retentivity. Our last is retentivity. So what does it mean? Retentivity. So how your data or your contents in memory remain, whether it is wiped off or not. Okay, so it is nothing but volatile or non-volatile. Okay, volatile or non-volatile. So if a sudden power off, or will the content lost during the operation if there is power cut off or power loss. So it would be volatile. If it won't, then it is non-volatile. So these are the types of retentivity. If we broadly talk about the location, so location resistor is very small memory, but it provides us the highest speed. Okay, and that is why we store all data or statement under execution would be in our resistor. Then main memory is random access memory, or in main memory whatever program under execution would be loaded. Okay, and the secondary memory, it is for the storage purpose. So whenever we don't need to execute that program, the extra thing or further process whatever we need to do on another day, we can store all those data on secondary memory. Okay, magnetic tape or magnetic material will useful to create the magnetic storage devices like magnetic drum, magnetic tape, and semiconductive like this um, RAM or ROM, whatever the memory devices we are going to use nowadays are considered as a semiconductive devices. Okay. CPU memory, inside CPU, whatever the register memory are considered as a temporary storage. Okay. While a secondary memory is a permanent storage. So it would be bulky and it would more time consuming to have data from secondary because it is far distance from the CPU, while resistors are faster because they are inside the CPU itself. So it provides us the faster access. Understand? So this is about the memory. Then next is the memory organization or size of memory. So we know what is 1 KB, 2 KB. Okay. Now we have one more thing. Let us withdraw. See, here we have number of address buses, then decoder, here we have bidirectional bus, and these are the chip enable and chip select. Here we have address bus, address bus. Here this is CE, chip enable, and this is chip select. Okay, this is M cross and memory. M cross and memory. And our final output would be a bidirectional. Bidirectional pulse. Why it is bidirectional? So if it is bidirectional, so you can share, we can send the data, or we can ask for address too. Okay, we have 5 minutes left with us. Quickly write down this all, and I will rejoin the same meeting. Please write down this all. First, this classification, memory classification would be asked for 3 to 4 marks, and second question about the memory. This is one chip or the memory architecture. Okay, block diagram for memory. It is neither ROM nor RAM. Okay, it's just a memory block diagram. Then after we are moving towards the ROM, but quickly write down this, then I will rejoin this meeting. Or as you can have a screenshot of the same, so we won't need to wait for anything. Just have a screenshot of this. Okay, let us rejoin it.